In this lesson, we're going to learn about multiplication of vectors by scalars, division of vectors by scalars, and how to determine the length or size of vectors. So first we shall look at scalar multiplication. If I have a vector A, which is equal to xy, then if I want to get k, the scalar k, times the vector A, this will be k into my A is x, y. So what will happen is I'll multiply this k, this constant, this scalar, by each of the components of the vector. So that will be kx and then ky. In other words, when we're multiplying a vector by a scalar, you have to make sure that this constant, a scalar is a constant, that scalar multiplies everything inside the vector. Let's look at examples of how we can do that. Given that A is equal to 2, 3, that's a vector A, which is 2, 3. Find 3A. Now to get 3A, we shall substitute. This is 3 times A, which is 2, 3. And like I just said, this scalar, this constant outside, multiplies everything inside the vector. So we shall have 2 times 3, and then 3 times 3. So that means that 3A will equal to 2 times 3 is 6, and then 3 times 3 is 9. So 3A is equal to 6, 9. Let's look at another one. If P is equal to 2, 5, find 7P and then 4P. So 7P will be 7 times P, which is 2, 5. And we've seen that you have to multiply this constant by everything inside the vector. So 7 times 2 is 14, and 7 times 5 is 35. Then Roman 2, 4p, this will be 4. P is 2, 5. So same thing, 4 times 2 is 8, and 4 times 5 is 20. So when we multiply this vector P by 4, we shall get this. Let's look at how to divide vectors by a scalar. Now, division of vectors by scalars is practically the same thing as multiplication of vectors by scalars. The ideas are the same. So for example, if I have a vector P, which is equal to maybe xy, and k is a scalar, then if I wanted to get maybe P over k, this will be the vector P, which is xy, divided by k. So it's like every element, every component of this vector will be divided by k. So that will give us x out of k and then y out of k, which is the same as just getting this 1 over k and multiplying it throughout. So the idea in division of vectors by scalars is the same as that in multiplication of vectors by scalars. Let's look at a few examples. Now, given that n is equal to 18, 6, find n over 2. So n over 2, we're getting a vector divided by a scalar. We have our n, which is 18, 6, divided by 2. The same as, I can even write it the same as a half into 18, 6. Because this is like 1 over 2 times this. So that gives us, when you're dividing a vector by a scalar, you'll get each element divided by that scalar. 18 divided by 2 is 9. And 6 divided by 2 is 3. So n over 2, which is like a half n, will be 9, 3. Example number 2. Given that OA is equal to 1, 6 and OB is equal to 7, 9, find AB over 2. Now we cannot do anything unless we have AB. So AB, this is a direction vector. You could even put the arrow. AB is the same as moving from A to B, and we saw it already. It's a direction vector. It is going to be OB minus OA, which will be OB is 7, 10 minus OA, which is 1, 6. And when we subtract corresponding elements. 7 minus 1 is 6, and 10 minus 6 is 4. So AB is this. Now we can get AB out of 2, which will be AB is 6, 4 divided by 2. And that means you get each of these elements and divide it by 2. That's how we divide a vector by a scalar. So 6 divided by 2 is 3, and then 4 divided by 2 is 2. That's how we divide vectors by scalars. Now let's look at how to determine the length of a vector. Length of a vector. In order to get the length of a vector, you need to know the vector itself. And first, another word that represents length is the magnitude, or the size of a vector. So the length of a vector is the same as the magnitude or size of a vector. So if I have a vector A, which is equal to xy, then the magnitude of A is given by, now to get the magnitude of A, it's written as this. These bars represent magnitude, and it is going to be the square root of, you get this squared, and then this squared. That's how we determine the magnitude or the length or the size or the modulus of a vector. Let's look at a few examples about how to determine the length of vectors. Find the length of A, which is equal to 3, 4. Now the length or magnitude of this vector A is written as this. When you see bars in vectors like this, those ones stand for the magnitude. So this is x squared plus y squared, which will be, in the place of x, we have 3, and in the place of y, we have 4. So this becomes 3 squared is 9, 4 squared is 16. This is the square root of 25, which is 5 units. So that's how we determine the length of vector A. Let's look at another example. Given that P is 6, -8, find the length of vector P. Now length is the same as magnitude, which is written as bar like that, this bar, and to be the square root of x squared plus y squared, which is, in the place of x, we have 6 squared. In the place of y, we have -8. Put the negative in bracket in order not to confuse the calculator. So this will be, this is 36 plus 64, square root of 100, which is 10 units. We don't know whether they are centimeters or meters, but they're units of length. So that's how we determine the length of vectors. We always just get all the elements, square them under a square root using this method.